At any given moment, thousands of passengers are moving in different directions. Families rush with bags, security lines stall, and announcements echo across the terminal. It looks like total chaos, but the entire operation is dictated by a strict internal clock. A delay of just 10 minutes at a single gate can ripple through the schedule, holding up runways, forcing missed connections, and freezing entire terminals. To function, the airport has to move millions of people, bags, and gallons of fuel every day without stopping. This requires thousands of tiny decisions to be perfectly synchronized, minute by minute. This coordination begins the second you drop your suitcase on the belt and the agent prints your tag. Once the bag disappears behind the rubber curtain, the journey splits. You, your luggage, and the aircraft enter 3 separate simultaneous timelines. For the flight to depart on time, these 3 independent paths, each with its own set of obstacles, must converge at the same gate at exactly the same moment. That tag is the bag's digital identity. It encodes the destination, flight path, and any necessary transfers, telling the airport exactly how to route the suitcase through the building. The bag enters a subterranean network of conveyor belts and sensors. It may travel for kilometers, moving through high-speed diverters and scanners tracking its location. The system automatically prioritizes bags with tight connections or diverts items that fail a security scan for manual inspection. This massive logistical investment exists because while a passenger might shrug off expensive coffee, a missing bag breaks the fundamental logic of the trip. Out on the tarmac, the landing triggers a high-speed turnaround. The aircraft is treated like a racing car in a pit stop, with multiple teams converging to service the cabin and the engines. This schedule is a sequence of strict dependencies. Cleaning can't start until passengers leave. New cargo waits for old cargo to be removed. If a single vehicle is late, that block on the schedule grows, pushing every subsequent task past its deadline. This creates a ripple effect. A delayed turnaround holds up the gate for the next plane, affects crew duty limits, and can force an airline to reschedule connecting flights on the other side of the world. The tarmac is a highly volatile environment, where one physical delay quickly multiplies into a massive network-wide problem. The third timeline involves the passengers themselves as they move through the terminal's checkpoints. Security and immigration function as risk filters. They're designed to allow a constant flow of thousands of people while isolating prohibited items and verifying every identity. The most difficult part of the system to automate is boarding. Moving humans onto a plane remains the primary bottleneck because people do not move with the precision of a conveyor belt. Airlines use boarding zones and priority groups to create order, but these strategies are often slowed by the simple reality of passengers blocking aisles or searching for overhead space. While software manages the bags and planes, the airport uses clear signage, loud overhead announcements, and strict queue barriers to guide human behavior into a predictable flow. Once the cabin is secured, the baggage loaded, and the ground crew clears the area, the 3 timelines finally converge as the aircraft pushes back. Now air traffic control takes over. This is the airport's nervous system, managing the paths of massive machines that burn fuel every second they are in motion. This radar display shows how controllers maximize runway capacity. They sequence arriving and departing aircraft into a tightly spaced line, maintaining the minimum safe distance to keep the flow constant. A runway is more than a strip of concrete. It is the ultimate limit on how many flights a city can handle. If the runway hits its capacity, the entire local economy hits a ceiling. The system's influence extends far beyond the fences. The airport connects directly to the surrounding highways, logistics warehouses, and business districts. It functions as a city engine, serving as the primary gateway for global trade, tourism, and the movement of capital. When this engine runs smoothly, the city is connected to the world. When it fails, the local economy feels the immediate pressure of the disruption. Modern travel is built on a foundation of blind trust. Every flight depends on an invisible army of thousands, baggage handlers, engineers, and controllers, all performing their tasks correctly. Designing a plane that can fly is a significant feat. But the real challenge is building a system that allows thousands of those planes to take off and land every single day across the entire planet with total precision. The next time you are waiting at a gate, You are watching a massive coordination of people and technology. You are sitting inside a system designed to turn individual journeys into a single global flow that keeps the modern world alive.